Hey, everybody. So, paying attention to the analytics for my channel, there's a lot of interest in hyperdimensional computing, which is interesting to me because I've only made one video on it. But I guess it makes sense because I assume that I'm one of only a few experts that are currently diving deep into HDC and exploring it. So, I want to make another video on it and then give you something high level to run with and play with yourself if you want to dive deeper into this concept of HDC yourself. So first of all, I want to dive into and explain a few things about HDC, and then first of all, why I think people are drawn to it. And I think people are drawn to it for three reasons, and all three reasons are interesting to me. But I think if it's like that, like Vince McMahon progression meme, to me, the first one isn't as interesting, the second one gets more interesting, and then the third one is what interests me. But so I think the bottom line is the first camp is there's a group of people within AI that don't think that we'll hit anywhere near like AGI or generalized intelligence or anything like that with current architecture. And they think that for a lot of reasons, but it all boils down to the fact that essentially current architecture doesn't mirror like how the brain works on a lot of levels, right? Backpropagation being one of them, being a big one of them. And so HDC overall as a method is far closer to the human brain. Like you'll hear a lot of terms with regards towards like neurocomputing and like neurobiology and things like that. And so all of that, like HDC falls under that camp and then solves that problem for those people. So like anyone that falls into that camp of like we're not going to hit it because of architectural problems, HDC solves. And then so that's like kind of the first camp, right? And then within that, to me it's personally not a big deal within that because I think like, like it's a feature and not a bug that AI is different intelligence than human intelligence, right? Like I think that intelligence overall is not human specific, right? And then so AI shouldn't be human intelligence. There's like a wheel of intelligence, and then AI is somewhere on the wheel, but it's not near or close to human, like which is fine, right? That's how it should be, and nothing wrong with that, in my opinion. But if you're in that camp, HTC solves it. Second camp is people that are very into graph theory. And then HDC is far, far more just, I mean, like leaps and bounds better when it comes to graph theory than current word vectorization methods. Like word vectorization methods, flat out, and I say this a lot, and I said this a lot from the beginning, right? They shouldn't work. That's the like it's when you look at AI models and you look at every part of it, the weakest part is word vectorization, which is why I've been going back to it for 2 years, right? And I keep going back to it because as someone that studied rhetoric and I just as a rhetorician overall, you just go back to this and it's like, this is overall the weakest part of AI, right? And then a weak part of it is that it stores the information in too few dimensions, and like the dimensionality is very low within it, and that's very prominent and very easy to see, right? As an example, like if I have a sentence as of the cat sat on the mat, if I translate that into bag of words word vectorization, that would translate into 21111, which is like that's like almost no dimensions, but somehow the models are able to do and translate 21111 into the cat sat on the mat. And then so if you give them 5,000 dimensions as opposed to 21111, they can only do better. Like there's no way that they could do worse with more information, right? And then that's how I look at it. And then every test that we've seen within that, it proves that like if you give models more context around things, that improves their outputs. And then so if we give them 5,000 dimensions or 1,000 plus dimensions, then I mean that's just overall better, right? And then so I can't see anything or any harm within that. And then so that's kind of the third point within this is that from a pure word vectorization, like a rhetorician, that whole standpoint, like philosophical standpoint, it just all jives better, right? So HDC is just an overall better concept than word vectorization. And then I want to notate this and explain this and explore this overall too. So HDC does two things overall. And I harp on one of them big time, but it does two things, right? So the first one is that it gets rid of backpropagation. So going back to that notion of it being more structurally like the human brain, the human brain doesn't do backpropagation. No brain does backpropagation. And then so that's kind of a big sticking point for a while since the 80s with AI, right? It's like, well, like backpropagate, no biological system ever does backpropagation, which is true. And then so HDC allows you to avoid that argument, gets rid of that argument, right? So it's only forward propagation. And then the second thing is that it's just storing this information directly, and it's very easy to update a model to be able to utilize this and test this and to train on this, right? So I guess that's kind of the next component that I want to highlight within this. And so the reason why we're looking at this GitHub repository is how easy it is for you to be able to go through and do this yourself, right? So I have essentially within this file, there's three scripts. There's the main.py, which is the main script. And then so this main script includes essentially our encoder and our decoder, right? So our HDC encoder and our HDC decoder. And then in this instance, we're putting it and we're defaulting to 10,000 dimensions. And then so one of the great things about HDC is that we can adjust this, right? So we can adjust it down to 1,000 dimensions. We could even go more than 10,000, but 10,000 dimensions is pretty good. So 10,000 dimensions. And then we can also adjust the sparsity, which is the the fractions of vectors that activate based off of the information. And then so this is using tertiary binary. So it's like the digits can either be -1, 0, or 1. And then so you get kind of like three of outputs within that, and the sparsity is like how adjusting, the layers within that. And then so the encoder and decoders are pretty straightforward. It's just, this is just it here. And then again, you only have a forward propagation, so no back propagation whatsoever. And then same thing here, it's just all feed forward, right? And then this is it as far as the main code. And then I have here this Llama HDC. And then so this is very straightforward, right? So you would run the main code. And then if you want to adjust the parameters of your Llama model, so you want to make your Llama model be able to use HDC for its encoder and its decoder, you just run this right here. And this is it, right? And then so this will allow the Llama model to encode and decode in HDC. But then you need to train it on a data set. And then so to allow it to actually understand and have things to encode and decode within HDC, right? And then so that's what this code is here. You want to definitely adjust this here, this define the data set. This is where you want to adjust and then put in kind of like a robust and big data set. You won't want to just train it on this because that's not gonna be very good to train it on like 3 words, but that gives you the starting point there for your data set, and then you just run this, and then it's going to take you however long it will take to run and train hours. Hours plus is what you'll be looking at there. But once you do that and you set this up, this is all that it is, right? And then so. This will work. I've set this up for a Llama model. If you want to hit me up, if you're interested in this, and then you're like, hey, I want to run this with this project, but I don't know how to adjust this for Gemma or Mistral or any other model, just let me know. I'll adjust this. I'll update this for any other model. I picked Llama because it's the biggest open source model, right? I figure if people are going to run with this, they're probably going to run with it with Llama. And then so I'm giving you literally everything that you need here. Just run the main script, the adjustment to your Llama model, and then train your Llama model on your data set, on whatever data set that you choose. And then that's it. It's all that there is to it, right? And then so this will adjust your Llama model so that it runs on your HDC, on this HDC encoder and decoder, which is the essence of hyperdimensional computing overall, right? The essence is in the encoder and the decoder. We can do other things beyond this. So then if this project takes off, like we can build out attention mechanisms. I can go through and adjust the training, like the training script, and then maybe there's better training mechanisms to use, etc. But like, as far as the power and the impact of HDC, it's all within the encoder and the decoder. And then so with that, I can give you an easy way to replace that. And then so rather than just like, make a bunch of videos talking about this and then going through, here's this GitHub repository. If you are super interested in this, literally just run this. It's like it's a total of 100 lines of code that you need to run in order to update your a pre-trained Llama model to utilize HDC. And if you have any questions, feel free to reach out. If you like this type of content, please like and subscribe. Thank you very much.